Okay, we're going to start learning target number 2, which is solving inequalities using addition or subtraction. So we're going to solve real simple one-step inequalities, but we're specifically just going to focus on addition or subtraction. So let's think about, and this is something that's going to carry through with this learning target and the next learning target, we're going to talk about equivalent inequalities and how you have to create equivalent inequalities. And your inequalities that are exactly the same or have the same solutions are called equivalent inequalities. They may not look the same, but if you were to plug in numbers or if you were to simplify one, then you can manipulate them to look exactly the same, and therefore they will have the same solution. So when we start solving inequalities, very similar to how you solve equations, you're just creating equivalent inequalities. Now, one concept that we're going to look at, the addition property of inequality, you have an addition property of equality when you're dealing with your equations. And that said, for my equation, what I add to one side, I can add to the other. And you all have done this multiple times. We're just going to take a look at what this looks like with inequalities. So I have this key concept box here. And what I want you to focus on is, we're just going to look at the words part of this. So I'm going to uncover part of this and leave the actual diagram covered up. But let's just look at what I have here. We're going to let A, B, and C be real numbers. Okay, so that means we have 3 different real numbers in this problem. And what they've said here is that if your A is greater than B, so actually let's just move this up so that we're not looking at the next part, so we aren't looking at too much at once. If A is greater than B, then A plus C is greater than B plus C. So I'm going to highlight that, or I'm going to rewrite this here in red. And basically what it's saying that if I add C to this side and add C to this side, I'm still going to have the exact same inequality statement. A greater than B, still going to have greater than here, even though I add the same number to both sides. Same goes for if you have A less than B. Okay? If you have A less than B, then what this is saying is that I can add C to the side with my A, and I can add C to the side with my B, and I'm still going to have a less than sign. I'm going to keep the exact same inequality statement. So these two, I've created equivalent inequalities. Now we can look at that. It says that it's true, also true for greater than or equal to and less than or equal to. But we can look at that with a couple of examples. Here's where 5 is greater than 4. So all I did was add 3 to the 5 and add 3 to the 4. And think about that. Is that a true statement? Well, what is 5 plus 3? This is 8. What is 4 plus 3? This is 7. Is 8 greater than 7? And it is. And the same thing holds true with your less than. You can add the same number to both sides and you get the exact same thing. Now, for those of you that might be a little more visual, this is just a diagram that illustrates this rule. But it's just saying if I have A and B, and for example in this one, A is less than B, B is less than A. B is behind A or here or in front of A if you're thinking from left to right. So it's less than A. So if I add C, it's going to jump up here. So it's B plus C. I added C to that B, so it's going to jump up here. But if I add that same distance, notice the distance I have from B to B plus C. If I add that same distance to A, I'm going to get A plus C. So it's the same distance from A to A plus C. When I add that to A and to B, I still have a less than symbol. My B plus C is still less than my A plus C. So this is just a diagram illustration for those of you who might be a little more visual with this concept. But we can add the same number to both sides and still have equivalent inequalities. Okay, so let's take a look at problem number 1, using the addition property of equality. So this is pretty simple, but let's just take this step by step. If this were an equation, if this said x minus 15 greater than negative 12, what I've asked you in the past is, how would you solve for x? What would you do so that x does not move? It's the only x we see, so I do not want to move that x. But what can I do to this inequality so that x is all by itself? Alright, well, I'm subtracting 15, and of course it does tell me to use addition property. But the inverse of subtracting 15 from x would be to add 15. But with the addition property of inequality, we add 15 here. To keep the equivalent inequalities, I'm going to have to add 15 here. Just add 15 to both sides. Now, just to double check yourself, this is always good practice, what is negative 15 plus 15? This will always make sure that you have the correct inverse sign here if you will do that. But if you have negative 15, positive 15, that is 0. So I am left with x greater than, and negative 12 plus 15 is 3. And there are my solutions, x greater than 3. Now notice that my solution is not 3. My solution is x greater than 3. This is very important with inequalities, different than equations. You cannot just give me 3. That is not the only solution to this problem. It is x greater than 3. Now we've only answered the question, what are the solutions? We also need to graph these solutions. So just like we did in the last video, we need to set up our number line. 3 is our starting point. We need to allow ourselves 1 or 2 numbers on either side of 3, making sure that we have our number line set up correctly, just so that we make sure we can go in the correct direction. Now, we're starting at 3, and we have a greater than symbol. We cannot use 3. If you plug 3 in here, 3 is not greater than 3. That does not work. So we have to start at 3, but 3 is not included. So that's your open dot, because we are not including 3. And we want x to be greater than 3. So would that be towards the 2, the 1, the 0, or would that be towards the 4, the 5, the 6? And for this problem, if we want x greater than 3, all of these numbers to positive infinity are greater than 3. So using the addition property of inequality, being able to solve for x to find all of the solutions, and then graphing your solutions. So what I would like for you to do is pause the video, take a minute, copy down your turn problem number 1, and solve that. Solve it for n, and then be sure to graph the solutions. If you have any trouble with this, be sure to ask before moving on. Otherwise, make sure you have this answered when you bring your note packet to your teacher. Now, hopefully you've answered that question, so we're moving on to problem 2. We're going to solve an inequality, and we're going to check the solutions. And we haven't actually checked any solutions, so this is something that we did actually do with equations, but we haven't done much of it with inequalities. So, what are the solutions of this inequality? We need to graph and check the solution. So multiple parts here to problem 2. Alright, so let's look at this inequality. First off, when you look at this, some of you may not be comfortable with the x on the right hand side. And you can move that. We can rewrite this inequality. We can create an equivalent inequality without even actually solving or doing anything. You can solve it this way, and a lot of people will choose to do that. So what I'm going to do is I'm going to solve it exactly the way it is. Then I'm going to go back and we can rewrite it so that we make sure our graph is correct. So identify that x is my variable, and I do not want to move that x. It's the only one I've got. I don't have to combine any like terms. That's the only x I have. So I don't want it to move. So I got to move everything away from it. So look at the right side of this inequality symbol. The only thing I have with that x is a minus 3. So just like in problem 1, the inverse of subtracting 3 would be to add 3. So 10 plus 3 gives us 13, greater than or equal to, and then negative 3 and positive 3, if you add those together, you do get 0. So I am left with just the x, which was my goal. And there's my answer. Now again, a lot of people don't like to see it written like this. They don't like the x or the variable on the right hand side. They'd rather it be over here on the left hand side. So you can rewrite this And you just have to make sure that your inequality reads the same. This is 13 greater than x, or greater than or equal to x, but if I read it backwards, it says x less than or equal to 13. So when you read it forwards and backwards, they sound different, but they do give you the same solution. So basically what you're going to do is just rewrite this backwards, x less than or equal to 13. Still, 13 is the largest number. It's facing the larger side of the inequality symbol. But those are two different ways that you could write your solution. Now, this way may be a lot easier for you to identify what direction your line needs to be shaded. So we've found the solutions. Now we need to graph it. So I'm going to set up my number line. 13 is my starting point. 14 and 15, I'm filling every other one here, 12 and 11. So we just need to decide which way are we going, where are we starting, how are we starting, which way are we going. So we're starting at 13, and it says less than or equal to. So that means that we are including 13. I can plug 13 in there and it will make it true. So we start at 13 and we do in fact include 13. And then I want x less than that. So I want to go x less than 13. So we have to think, would that be towards the 14, 15 or towards the 12, 11, 10, 9? And if I want everything less than 13, I would go in this direction. Now you can always double check that with the original answer you got here. Is 13 greater than all of these numbers? Well, for example, 13 is greater than 11. And that's part of your check. So you should always check your endpoint. Well, my endpoint says that it's included. So I'm going to check my endpoint. This is my check here. I'm going to plug 13 in for x. Is 13 less than or equal to 13? Yes, because it's equal to. Alright, so pick a number in your shaded area here. For example, I'm going to pick 11 and plug that in. Is 11 less than or equal to 13? And when you look at that, it is. 11 is less than 13, so that is a check. You could also check going in the other direction. You could give yourself, say, the 15 and plug 15 in. Is 15 less than or equal to 13? And 15 is not less than or equal to 13. This is not true. So you are correct in the fact that you did not shade this direction. So your check could include correct and incorrect answers just to make sure that you are shading in the right direction. Alright, so for your turn, problem 2, what I'd like for you to do is make sure that you solve this for M, graph it, and then check your solutions to make sure that your graph is correct. So make sure you pause the video and give yourself a minute to answer those questions. Alright, so hopefully you finished your turn problem there, and we're going to move on and look at the subtraction property of inequality. Now it's almost exactly like the addition property of inequality. So we're going to take this a little bit at a time. We're not going to cover up, I'm not going to give you the diagram just yet. I want you to focus on the words. So we're going to look at this first one. Let A, B, and C be real numbers. A is greater than B. Well, if A is greater than B, and I subtract C from A, and I subtract C from B, I'm still going to have an equivalent inequality. I'm still going to have A larger than B. A minus C is going to be larger than B minus C. So I can subtract the same thing from both sides. The same goes with if A is less than B. I can subtract C from A and I can subtract C from B. Notice I'm subtracting the same thing from both sides. And I still have an equivalent inequality. I still have a less than symbol. The same thing goes for your greater than or equal to and for your less than or equal to. And with this subtraction property of inequality, we do have a couple examples that we can look at. The first one is negative 3 is less than 5, which is a true statement. Negative 3 is less than 5. So I could subtract 2 from negative 3, and I could subtract 2 from 5. And think about what you would get. If you're down 3 and you go down 2 more, this would be -5. We're down 5. If I subtract 2 from 5, 5 minus 2, this just gives me 3. Is -5 less than 3? And that is true. So it does hold true with subtracting the same number from both sides. Just like it holds true if you have a greater than symbol, you can subtract the same number from both sides and you still have a greater than symbol. Now here's your diagram here if you would like to look at that. It is similar to the last diagram that we had. We have A less than B. So this could be 4 and this could be 7. A less than B. If you subtract the same amount from B, that gives you B minus C. Remember, it knocks you backwards when you subtract. If you are at A and you subtract C, it knocks you backwards to A minus C. You can see where A minus C is still less than B minus C. So just a diagram there, a visual of the subtraction property of inequalities. Now, let's use the subtraction property of inequality and let's apply that to problem number 3. Using the subtraction property of inequality here in problem 3. So we're going to know what are the solutions to this inequality, and we are going to graph these solutions. Now, notice that it doesn't say to check your solutions. So even though it doesn't say to check, it's always good practice, whether you write it down or whether you type it in your calculator or talk it out loud, to make sure that the graph you have is correct. So we have t plus 6 greater than -4. Well, t is the variable that I have that I do not want to move. It's the only one I've got, so I don't have to worry about collecting like terms. So I got to determine what do I need to do to keep that t there and get everything else away from it. I got to move everything to the other side. Well, the only thing I have is a plus 6. So the inverse of adding 6 is to subtract 6. And the subtraction property of inequality says if you subtract 6 from both sides, you're going to have an equivalent inequality. Well, I have my t that I have not disturbed, and I have plus 6 and minus 6, positive 6 and negative 6. That gives me 0, so I'm left with greater than -4, -6. So it's very careful. Be very careful here. I have a couple of things. Make sure if you're typing this in your calculator that it is in fact a -4. And the other thing is, this is just a -6. This does not read minus a negative. You do not see two negative signs here. You just see one negative sign. Negative signs, subtraction signs, interchangeable, mean two different things as far as one's an operation and one's determining the sign of a number. But they are the same thing. So you can read this as -4 minus 6. Okay, so make sure you're careful if you type that in your calculator. Now think about this logically though. If you're in a ball game and you're down 4 points and you go down 6 more points, then you're going to be down 10 points. So -10. So those are my solutions. Notice it's not just -10, it's t greater than -10. So those are my solutions. And now let's graph those. So set up my graph. My starting point is -10. Now be very careful setting up your number line. If we want to go smaller than -10, this is going to be -9, -8, or larger than, excuse me. Larger than -10 is -9, -8, and smaller than -10 is -11, -12, and so forth. So just like I just said it wrong, be very careful. These numbers are getting larger than -10, and these numbers are getting smaller than -10. All right, so -10 is my starting point. And we need to determine open or closed dot. Are we including -10 or not including? Well, this says t greater than -10. Doesn't say equal to. That means t -10 is not greater than itself. So we have to start at -10, but we cannot include it because it does not work in our inequality. Now, which way is t going to be larger than -10? Which side of your dot must you shade in order to have larger than -10? And that's going to be to the right. All of these numbers, you're going to eventually get into your positives going in this direction, and all positive numbers are definitely greater than -10. So that makes it very simple to determine. So there's our solutions, our graph, and then mentally check that. And like I said, you're going to wind up even at 0. that would be an easy one to check. Is 0 greater than -10? And yes, it is. So take that problem and apply it to the your turn problem. What are the solutions of this inequality? And then graph those solutions and make sure that you check it, whether you write it or you type it in your calculator or you talk it out loud. Make sure that you check your solutions in order to verify your answers. Now, take everything we've learned that we've done with subtraction and the addition property, and we're going to apply that to a word problem, writing and solving an inequality. All right, so one thing that might be helpful to you is having some highlighters close by, because then it just allows you to be able to highlight different things and make sure that you know the parts of the word problem you need. And let's read through this. So I'm going to grab a highlighter. The hard drive on your computer has a capacity of 120 gigabytes. Well, I feel like this is going to be important because it talks about capacity of. So think about if you had an iPhone, this would be an enormous amount of space on your iPhone, but a capacity of 120 gigabytes. What this means is that your hard drive on your computer will hold that much, 120 gigabytes. That is its capacity. You could also think of it as its maximum. Okay, so think about your phone. If you're trying to download something to your phone and it doesn't have enough space, then you've reached capacity and you can't go over that. There's no leeway there. So this one, 120 is the max. Now, for your computer, you have used 85 gigabytes. So you only have 120 that you can use, and you've already used 85 of it. All right, so what we want to know is you want to save some home videos on your hard drive. So what are the possible sizes of the home video collection you can save? Okay, so we know how much we're allowed to have. We know how much we've already used. What we want to know is the possible sizes. What are the possible sizes of the home video collection? I know that's sort of hard to see a little bit. What are the possible sizes of the home video collection that you can save? So let's start breaking this down into all the parts here. First of all, the best practice is to actually identify your variable up front. So I'm going to identify that I'm going to use x as my variable, and I want x to represent, we need to write in what we want x to be. I'm going to put home video size. So home video size. That's what x represents. So I've defined my variable. That way if somebody looks at my equation, then they know what the variable represents, so they know what the solutions should reflect or should be or what they represent. All right, so I've defined my variable, so now I need to think about this. This is how much I've used, this is how much I want to put on it, and this is how much I'm allowed to have. Well, if you've used this much and you want to add more to it, that's exactly what you should do. You take how much you've already used and add how much you have left to use. Okay, so I've got 85 gigabytes already on my hard drive, and I'm going to add to it however many gigabytes of home videos I'm allowed to have. And in equations, when we were talking about equations, we would set this equal to the 120, because then I would just ask you, well, how many gigabytes are you allowed to have now? Well, it's still similar with inequalities, but you may not have exactly 120 on your hard drive. You may wind up with a little less than that. Now ask yourself this, can I wind up with more than 120? Can I wind up with exactly 120? So when we're trying to set up our inequality symbols, remember we have less than, greater than, less than or equal to, greater than or equal to choose from. Okay, well let's think about this. Am I allowed to have on my computer more than 120? No. So this one and this one are definitely out of the question. I can't have more than what I'm allowed to have. That's my capacity. Now, can I have less than 120? Yeah, I already have less than 120 right now. Can I have less than or equal to 120? Yes, you could have exactly 120 capacity on exactly 120 gigabytes on your hard drive. So the one that we're going to go for here is the less than or equal to symbol. So you've written your inequality. We've defined our variable. We've written our inequality. So now what we need to do is we need to solve this for x to determine the different sizes we're allowed to have for our home videos. So this is understood to be a positive 85. There's not a symbol out here or a sign, so it's understood positive. The inverse of a positive 85 is a negative 85. This would be like, I could read it backwards, x plus 85. So the opposite of adding 85 would be subtracting 85. Always be careful with writing backwards though. So subtract 85 from both sides, and this leaves me with my positive x less than or equal to, and 120 minus 85 is 35. So, while this is my solution and it is correct, I can have any size video as long as it's less than or equal to 35 gigabytes. I can have multiple videos as long as when I add them together they're less than or equal to 35 gigabytes. So that's what you need to make sure that you define. And I'm just going to write out a sentence, especially since this is a word problem. It's always good to conclude what your inequality is actually stating. So the home video can be any size less than or equal to 35, and that 35 represents gigabytes. So a nice simple sentence that sums up what your inequality tells you so that someone reading this knows what the 35, they know what it stands for, but just to make sure and to verify what your answer is. So take what we have here, define your variable, highlight the important information, define your variable, write your inequality, and then make sure that you conclude with a valid sentence and apply that to your turn question, problem 4. Make sure that you pause the video and go through that question and answer that question, that word problem, just like we did the problem 4 together. Alright, so hopefully you've completed that one. Make sure you ask for help if you are not sure where to start, how to finish, whatever you have trouble with that problem. Be sure to ask. So here are your summary questions for this learning target. Solve and graph those following inequalities. There are 2 of them, A and B. Solve and graph, so make sure that you not only give us the solutions but also the correct graph. It's always good practice to check, make sure your graph is correct. And then 2 is another word problem that I want you to focus on, just like problem 4, to solve that word problem.